So the bevel grind is basically perfect, is what you're saying.
Yeah.
There are literally just knives stuck out of the back of it.
You drop this and it's likely to shatter.
This is like wizard to me.
It is.
There's a couple more steps happening with the Sonora.
And one of them gets kind of crazy over here.
Yeah, one of them gets a little crazy.
It's definitely not a knife yet, right?
No, it doesn't look like a knife yet.
So what happens with these is we actually surface grind the bevel.
So, on this?
On this.
These will warp all sorts of directions.
Yep, and those are the most critical dimensions.
They are what makes this knife work.
I mean, it can be described in no other word but Machinewise.
What's up, everybody, and welcome to another video here at Machinewise HQ. This is the second in our series all about how Machinewise makes their products. And last time, Dalen showed me around the new shop, and then I got to talk to Martine all about the design process and the ethos of Machinewise in general and how much they have grown. Now, today, we're gonna deep dive into the actual manufacturing process and learn how we can go from a raw material like this into a beautiful finished part like this. And to do that, Martine has passed me off to some of the other employees here at Machinewise. And so, because this shoot went a little bit later than people were willing to stay, I have Martine with me here.
Hi, Will. It's nice to have you back.
Oh my God. Hi, Martine. How did your wizard work go?
Oh, it was awesome. You know, I just casted Fireball and we have some ovens here.
Oh, goody. So Martine is gonna walk us through the beginning of this process, and then a little bit later, we're gonna be talking to Jacob, I believe?
Totally. So Jacob's gonna take you through the handle process, but I'm thinking maybe about now we can talk about some blades.
I would love to talk about blades.
And really, blades start at heat treat. We are fortunate enough at Machinewise to get our blanks cut for us outside or out of house. Cool. This is one of those processes that we've decided we don't want to bring in-house. Blanking is a pretty big process in the sense that you have to have some pretty big machinery and square footage, either a big laser cutter or a water jet. And that's, well, we do have a bigger shop, but we're not a big shop yet.
Gotcha.
So we get our blanks cut for us, and then they arrive at our house like this.
So this is basically from a large sheet of metal.
Exactly.
Is this anywhere close to the actual dimensions of what you're going for? Or is this pretty loose?
Absolutely not. So we take our actual final dimension, we add a significant margin around the entire perimeter and all the holes.
So this has pretty big margin of error so that you can make it perfect from here.
So at Machinewise, we do hard milling. This piece is gonna get entirely hardened to its final hardness before it gets machined at all.
Oh, okay,
in our process.
gotcha.
So the reason we do that is because if you harden first, this part isn't gonna move anymore as you're machining it. If you machine first, things move in heat treat.
Right.
Heat treat lets things get really hot and they relax at that heat.
Yep.
And then you cool them down real fast and they freeze where they were relaxed. If you machine first and then heat treat, you always have the potential for things to move, which isn't great when you're trying to keep really tight tolerances.
Okay, so preventing that requires heat treat. What is the process of heat treating?
Absolutely. So we have this blank, right? And this arrives in its soft state. And so what we're gonna do is we're gonna put it in our left side oven and we'll load up a few blades into the oven. We do 3 at a time. We'll insert 3 blades and these will go up to, depending on the steel used, a prescribed temperature. And that's gonna be our quench temperature. The quench temperature is what's gonna actually harden the steel. So what's gonna happen is these are gonna go in, they're gonna get nice and orange and real hot.
Okay, so they're like red hot by the time
Oh
they're
yeah,
out of there.
these are do some damage hot. So not only do you need to get up to that temperature, but for these really cool premium steels, these powder steels,
Gotcha.
right? Powder metallurgy is something really cool, and if you're interested, viewer, you should absolutely research it some more.
Is this like S35VN, S90?
Yeah, so, and it's for Crucible, it's the CPM.
Right, okay,
So
got it.
the PM is powder metallurgy.
Oh, I did not know that.
So that's where you can have like 154 CM, and then you have CPM 154. They're chemically the same, but one of them is the powder version and more premium. So we'll then pull these out and they'll go into our quench plate. 1, 2, 3. And then this quench plate smushes them.
Oh wow, it really pushes down.
Oh yeah, and that force is keeping them straight as it cools.
the quench plate last time was nothing like this. I think it was just like a single blade could fit in there at a time, and you kind of like pushed it down on an arbor press or something.
Yeah, exactly. It was 2 aluminum blocks in an arbor press. And so now we've upgraded. This is our friends over at Fellowship Blades, Grant.
Shout
He
out
designed
Grant.
this for us. This is a new venture he's gone into. And so this is able to apply a constant force through the springs, and it's way more efficient for us.
Okay, so after they go into this thing, what happens?
Yeah, so we have our soak time, and our soak time is guiding everything.
Okay.
So we'll go from soaking at the high temp, this is gonna quench it, and this is gonna bring it down to room temperature.
Right.
But we wanna go further. And so once they're out of here, they'll come out, and this blade blank will then go down into liquid nitrogen. And so this is the cryo component of
Oh
a
my
cryo
gosh.
heat treat. So this blade blank then gets dropped in
Oh,
and will hang out in liquid nitrogen for about 30 minutes.
wow.
Yeah, and so if you think about it, we're going from 2,000 degrees down to room temperature.
Okay.
It's like 1,900 degrees in a drop, right?
Sure.
And now this is negative 500 degrees. So we're now dropping another 600 degrees, going down to that.
Okay.
Which, percentage-wise, is a really big drop.
Yeah.
That you go further. And the reason we do this is it's about retained martensite and austenite, right? And so austenite is soft steel.
Okay,
Martensite is hard steel.
got it. This is like wizard shit to me.
It is. So what we're trying to do is we're trying to get as much martensite as possible.
Okay,
What makes steel hard is when you heat it up, everything gets loose, right?
and so that's forming the crystalline structure while it's sort of hot and loose.
Exactly.
Okay.
And then you want to freeze it.
So it
and
stays
keep
there.
it like that. Going from here to here, you save a lot of that in that crystal.
Okay,
But by going from quench even colder,
so like
you
negative
save
600.
even more as a crystal.
Gotcha.
And so this is less about the hardness and more about the consistency through the steel.
Okay, so you're just trying to have it be not just hard, but consistent.
Exactly.
So after it takes this bath in liquid nitrogen, what happens?
Yeah, so they'll come out of the liquid nitrogen, and now we have something that is really hard. But this is too hard to use as a knife, much less a balisong. You drop this and it's likely to shatter.
Really?
Right? We have glass on our hands.
Oh my God.
Right? So what we have to do is we have to temper this. And so tempering is saying, well, you got really hard, now I want you to relax, but only so much.
Okay, so just a little bit.
Right,
So you're basically getting it as hard as you can,
yes.
and then you're bringing it back down just so it's at the perfect kind of Goldilocks zone.
Exactly, we're reintroducing that toughness.
Got it.
In a knife, you're expecting performance from, especially cutting performance.
Right.
The heat treat is everything, because the heat treat will define how long it'll hold an edge, how it will take abuse. Will that edge be chippy? So maybe you're cutting something and you hit a staple.
Right.
And you don't want your edge to just chip out when you hit that staple.
Right.
Getting this exact and consistent is really important, because it doesn't matter if I get one Goldilocks perfect blade and I sell that to a customer and I'm like, here you go, it's the perfect one.
We did it one time.
If the next 99 are terrible. And so all 100 have to consistently be good.
Okay, so once a blade blank is at the proper hardness,
Yeah,
whatever that target may be, does that change product to product?
it does.
Okay, so-
and it changes steel to steel.
I guess that makes sense. So once you've got that exact hardness that you're looking for, what happens to the blade blank next?
Once they're done with temper, we'll take them over to the surface grinder and they're gonna get their first pass at machining.
Do you want to go check that out?
Let's do it.
All right, let's go look at the surface grinder. Okay, so this is our surface grinder.
That's right.
What happens here?
Well, it makes them flat.
I do like it when it makes it flat. That is a good thing for it to do. But why is that important?
Yeah, so not only does this machine make things flat, it also gets them to a consistent thickness.
Which is very important, I would
Which is
think.
really important, especially for bushings. Here we have some stock that was heat treated a couple days ago. We have a few different blades and our lock bar insert stock. All of this stock, it needs to get to a consistent thickness and it needs to be well made flat.
Okay, so this is what is kind of the result of what you've done here.
Exactly.
This is something that has been made nice and flat, which you can, I mean, immediately perceive just from the look difference. I mean, it's still darkened on the outside, but this has that nice machine finish, whereas this is a kind of a hot mess.
Exactly.
If I remember from last time, basically the idea here is that with this nice flat starting point, this is kind of a reference for the rest of the process to happen to it.
You hit the nail on the head, yeah.
I learned.
What we're doing, we're now establishing our first datum or reference plane. So this is a really weird, misshapen, not quite right part. And so this is our first attempt at getting us a consistent surface. And then once we have one consistent surface, this is our foundation. And then using these, we have the foundation to go over to our mills and get our actual profile geometry.
So we're going from basically this that has the tags, the excess little parts and stuff like that, and we're taking it and turning it into something that has like some of the locking parts and some of the other parts that kind of make it work as a blade.
Exactly. But you know, it's kind of weird. This is missing something. It's definitely not a knife yet, right?
No, it doesn't look like a knife yet.
Well, this is not gonna go back to the mill. So what happens with these is we actually surface grind the bevel.
So, on this?
On this. So our surface grinder has CNC control.
Okay.
And so using that, we've been able to, do our bevels on the surface grinder.
Wow.
And so we have these custom blocks we made, and these are just they're like a mini pallet, right? And these pallets with this back face, they interface with the mag chuck. If we look at how these go, with the mag chuck, they don't quite go straight. They go at an angle, and that's the plunge line.
Right there you go.
That it's matching.
Right.
And then that wheel comes across and gives you a perfectly flat bevel. We actually hold it at a compound angle. So it's not just up, it's also up.
Oh, cool.
And so this angle is really specific.
This is a great example, right? This piece is the same flat piece that you're seeing here. And so this part right here that's kind of sticking up from this chuck, that's just gonna be removed.
Completely.
This piece right here is the result of that, right? The planer has come across and now you have a nice flat profile there, which means that this is now bevel ground. And you're doing all of that in a very creative way using the surface grinder.
Yeah, and what's crazy and like a funny and pretty Machinewise byproduct of this is that those bevels happen to be surface ground accurate.
So the bevel grind is basically perfect, is what you're saying.
Yeah. I mean, it can be described in no other word but Machinewise.
That's fair. I guess Machinewise itself is just a little bit weird.
That's right. A little bit extra.
A little bit extra. Extra's a good word.
Yeah.
We like things when they're a little bit extra.
Once we're done with this, we have a finished blade. However, we don't have a finished blade. And so we're done in the machine shop, but now this needs finishing to really put that final touch on it, to take it from a rough, sharp, machined product and get it to something that would feel nice in the hand.
Okay, cool. I am excited to learn about that process, but I was promised to also be able to learn about some of the titanium because this is only half of the knife.
That's right. Well, we're missing a lot. You need something to hold on to, right?
Yeah, that would be a little hard to cut with.
So I'm gonna hand you off to Jacob, our head machinist, and he's gonna take you through the rest of the process of making the handles and the rest of our titanium parts.
All right, cool. Can't wait to learn.
Well, I got some more summoning circles to get done, so I'll see you later.
Martine? Martine? Martine! And so here we are with Jacob to learn all about the titanium half of the machining process. Last time I was here 2 years ago, you were still doing this, but has your job changed in the time since?
I'm still the head machinist. The only difference now is that I'm actually in charge of some people.
Right, last time you were the head machinist and also kind of the only other machinist than Dalen, eh?
Yes, also the head grinder, head heat treat, a little bit of finishing in there too.
Oh my God.
I've been able to focus a lot more on specifically what my job is now.
I think that's for the best. So you are kind of in charge of everything going on in the machine shop to some degree. I know behind us right now, for those of y'all watching at home, there's this kind of like sighing sound happening continuously in the background. That's because this guy back here is making serif blades as we speak, which I have a feeling we have some very pretty B-roll of. But these are happening, and I can't really do anything about that sound, so it's just part of it, sorry. But today we're gonna be learning about all this. You've kind of set up a little show and tell for me here.
Yep, I gave us a decent little display of a completed operation and one that's ready to go into the machine on each half of the pallet here.
Take me through this. I mean, we just learned about how the blades are actually made. What is kind of different about what's going on with the titanium versus the blades?
So the first difference is that the titanium is not a hardened metal. They are a lot softer and therefore a little bit easier to work with.
Okay, so are you doing anything at the heat treating process to the titanium? You're not hardening it?
So we don't have to harden it. The only process that our titanium goes through before they end up on a pallet is a real quick annealing process.
Annealing.
So an unannealed piece of metal will be fairly rigid. You wouldn't think it has stress in it. But when you start removing material, that stress likes to start showing itself, especially when you're going from a solid rectangle like this to something pretty finely machined. You can see quite a bit of the metal disappears. So any bit of stress in there now has a lot less material to keep it from showing. So without that annealing process, these will warp all sorts of directions. They will go into the oven, get nice and hot, and it relaxes the metal. Right after annealing, they go through a quick facing operation. And all that does is it takes an end mill and it cuts the top off of this to give us a known dimension. When these come from the distributors, they have slight variances. So we get one face cut off and one end cut off to make sure that we always have two known dimensions to put onto the pallet.
So if I remember correctly from last time, we talked about the serif a fair bit, and it was pretty straightforward. You have your starting piece, we remove that, get our reference dimensions, pop it in here, and it's what, a two-step operation, one side then the other? This looks like there's a lot more than two steps happening.
There's a couple more steps happening with the Sonora, and that's partially due to it being a fully integral handle. The serif handle, we have 2 points that are always going to be there. That's the pivot points. And those make really good reference points to move into the next operation. With the Sonora, almost every part of it has some type of radius, some type of geometry on it that makes it so it's almost impossible to machine in 2 operations.
Right, you have to get to some other side of it to do something to that side.
Yes.
I see.
Like we have to think of this pallet in 3 dimensions. So our 4 steps that happen on this pallet are in order. We have our first operation where it goes from a straight up brick of titanium where a lot of the geometry is added initially.
Literally a handle just kind of emerges out of this solid piece of titanium.
You can see here, the only bit that's left that's not finished is the part that has to stay fixtured to keep this rigid.
Oh wow, so even the channel is cut in at this point.
The channel ends up in the op 1 and our critical dimensions for the button and lock pins happen before the channel is put in. If this channel was done first, this part would have too much vibration to maintain accuracy for those critical dimensions.
Yep, and those are the most critical dimensions.
They are what makes this knife work. From op 1, this part will come out nearly complete, and we take our existing channel that we just made in the op 1. So it'll take this nice, lovely shaped clamp, slide right in. We would pop the screws in, and it's ready to rock for op 2. And we have a recessed groove machined into here. That's the exact profile of the blade that once it just sits in there, it'll lock in, and we screw it down, and it's ready to go.
And it'll just kind of cut all of this stuff off, and you're left with the beginnings of a handle actually forming.
Exactly. So this is a finished op 2, and all it's done is it's taken this unfinished side, cut off all that excess material, and has now begun facing the next operation for op 2.
What is left to do on this handle? Why are there, I see at least 2 more, and one of them gets kind of crazy over here.
Yeah, one of them gets a little crazy, and that's because we wanted some nice geometry on the spine.
Okay.
It's like we wanted this knife to look pretty from every direction.
Right, because right now it's just completely flat on the spine.
So right here would be a completed op 2 that has moved into op 3.
Okay.
And when it's in op 3, there is a brass nut that we use to squish the part against the pallet to make sure it stays solid in there. So we have this little brass nut that sits right on the other side here. And you loosen it, and it's got a cam nut in there. Now, this Allen screw is not perfectly circular. It's got what's called a cam head screw in it.
Oh.
So it's actually slightly oval. So when you loosen and tighten it, it pushes up against the nut, and it'll tighten the part. Then this will pop up, and we have our little spacer in here whose sole purpose is to give this brass nut something to press against.
Right, because otherwise it's kind of squishing
Yeah, you
the
can
channel.
squish these a tiny bit. We want it to stay rigid in there and not lift out. So in this op 3 process, it will get a nice little chamfer on this inside here. We get our logo nicely machined in there, and some aesthetic grooves put in, and some chamfers put on those so they stay nice and smooth. Most people who carry pocket knives like to have a pocket clip.
Sure.
But as you can see, coming out of the first 3 operations, operations, there's nothing here. And in none of these operations is there a good way to get at this direction with a tool. Our only solution, due to the geometry of this part, because if you look at it, everything has a radius, everything has a slight bit of arc to it, and that makes fixturing very difficult. So we had to mount them on the side of the pallet, and as you can see, they are just straight up sticking out of the bottom there.
I found that so weird when I walked around here. I was like, oh wow, this pallet looks interesting. And I got around to this side, I'm like, there are literally just knives stuck out of the back of it.
That is unfortunately the only way we could easily get these to mount in a repeatable way.
I kind of love that though. Like that feels like a very creative solution to me, which is very indicative of Machinewise.
Once they are in this position, we now have good access to put a lanyard hole, clean up this little facing here for a clip to properly sit, and then drill and tap a hole. And then we can just pop this right out by loosening the same cam head nut on the other one. Pops right out.
It made a very satisfying pop.
It popped right out of there.
Wow, look at that. And then you have a nice crispy piece. What at this point are you kind of looking for before you hand this off to the next process?
So there are a couple checks that happen throughout this process.
Okay.
So in the op ones, I have check pins that go into each one of these holes to make sure that they're within our dimensions. Two more visual checks that I do is I make sure this gets a full cleanup on that seat in there, make sure it's nice and pretty. Then I have a check screw that I'll screw in there to make sure the threads are still contacted fine.
Is that check screw anything in particular, or is it just one of the screws?
We just call it a master screw, but it's honestly just one of the screws that we first made, and it's a standard Machinewise screw.
Oh wow, okay, yeah, this is like the exact kind of thing that you see on like the tutorial.
Exactly. This is one that we've checked and made sure it is exactly within all of our tolerances and good enough to be a check screw for the handles. This part will go over to the check table now and move on to finishing.
Can I bring it to the check table?
You can.
Very exciting. Thank you so much for showing me how this works. I am very excited about this process. All right, I'm gonna go deliver this.
All right.
Okay, so I've got these parts and I was told to bring them here to the machine shop checkout table so that they can go to finishing.
Halt! You shall not pass. QC.
Oh, I guess that's a good point.
Yeah, we gotta check through these parts and make sure they're good before they head to the front of shop.
Yeah, I guess it would be kind of bad to just send this on and not check that it actually works, huh?
Well, exactly. So here at Machinewise, we need to check these parts at every step of the way.
So this table then kind of acts as that in-between point between the machine shop and the finishing stage?
Exactly. So the guys in the front of shop, they're allowed to take stuff off this table, but not any of the others.
Gotcha.
And so this is as far into the machine shop that they can go.
What is the QC process like? I see a sort of handled checklist here.
Yeah, so I brought this checklist over from the machine for you. This is a quick checklist where we can check this part with a bunch of master parts and make sure all of those fit. Those master parts work like check gauges, and they give us a really quick go, no go on every single part to let us know if those parts are okay to go forward in the shop.
So I see like B, pivot hole, check fit with test pivot. So if a pivot doesn't fit into this hole, obviously that's no good.
Right, we'll have a problem. And the pivot that we use to test that hole is a really specific pivot that we know the size of.
Okay.
And so we've made that pivot in order to check that hole. And so if that pivot fits, we know all the rest of our pivots will. The benefit of it is that allows us to catch problems really quickly. We actually have a stop, kind of like this, at the end of every process.
Okay.
The reason we're doing that is we don't want all the pressure of QC to be on machining. We want the whole team to bear the weight of making a great product. Sometimes something can sneak past our machinist eyes.
Okay.
And when it does, hopefully finishing catches it. And if they don't, assembly might. And if assembly doesn't, final QC will.
This is kind of the last stage of the machine shop process.
That's right.
then. So this is gonna go to finishing, which I'm going to learn about in the next video, I guess.
That's right, we're gonna hand you off to Quoke at finishing, and he's gonna take you through that whole process to show you how a rough machine part can go to a final part that's ready for assembly.
Awesome. I can't wait to learn about that. Though I'm suddenly realizing I think we may have skipped something because we don't have the things that actually hold the knife together yet, do we?
Well, that's right, and you know, I think Pierce wants to talk to you about the lathe.
Okay, cool. So I'm gonna get to learn about that as well?
I would really like you to.
All right, sweet. Well, I'm looking forward to the next video. Make sure that you subscribe and check out this entire series because we have unfettered access to the entirety of the Machinewise process. I am very excited to learn about each and every step of this. This journey has been incredible so far, and I only imagine it gets even more cool from here. So thank you so much for watching. Thank you so much for hosting me and
Absolutely.
being your little magical self. And,
I do try.
Man, if you want one of these products, if you want something amazing from Machinewise, check out our discount link, machinewise.willhirsch.gay, and we'll see you in the next video.
There be goblins in these walls.